Hi YouTube, you are watching Simple Coding. This video is a part of a tutorial series about how to build a microservice using Spring Boot. In today's video, I will show you how to create a database for a microservice and how to create Object Relational Mapping classes based on Spring Data JPA. This tutorial series is for Java developers who have never done any web application development or are not familiar with Spring Framework. In today's video, I'm going to cover these topics. Common characteristics of a microservice database. What is JPA? And its relationship with Spring Data JPA and Spring Boot JPA Starter, which is the library I'm going to use in this video. How to create two Object Relational Mapping classes within Spring Boot and how to use them to automatically generate a database. So let's get started. As I mentioned in the first video of this tutorial series, a microservice communicates with its own database. This is because one of the goals of microservice architecture is to be able to update each microservice independently without impacting other microservices. Here are some important characteristics of a database designed for a microservice. Usually, one microservice only manages one database. The database is private, meaning no other microservices can access it directly. All the data stored in that database are tightly related to each other. The boundary of database transaction is also within the database itself. This architecture does impose some challenges in some cases, and this is one of the cons that people have pointed out about a microservice. Due to the nature of microservices as components of a large service, the size of a microservices database could be small. If you use a relational database, the size of a couple of dozens of tables is quite common. Within this video, I'm going to talk about using relational database for the microservices. As you may already knew, JPA stands for Java Persistence API. It's only a specification, basically a set of requirements. It contains a specification of 4 components. Object Relational Mapping, ORM, which defines standards on how a plain module can be mapped to a table and its relationship with other tables. In ORM, each table is usually represented by one Java class called entity. Java Persistent Query Language, JPQL, which is a query language similar to the traditional SQL. It is designed to be used by JPA to perform data operations on each object of an entity class. Conceptually, JPA will interpret a JPQL query, extract the data from entity class objects, perform the actual query with the relational database directly, and put the data returned from the database into the same set of entity class objects. Entity Manager, which is the core Java object that controls database operations within JPA. Transaction Functional Standards, which specify how to commit data inserts and changes or rollback as needed. Since JPA is just a specification, it must have an implementation to make it available as a Java libraries. Each such implementation is called JPA provider, and the Spring Data's JPA is a JPA provider, which is based on Spring Framework and Hibernate. Hibernate itself is another popular Java framework. In addition to standard JPA functionalities, Spring Data JPA also extends JPA with a Spring-specific concept called JPA repository, which is based on a Java pattern called repository and provides a unique mechanism to simplify database operations through JPA. To utilize Spring Data JPA within Spring Boot, the simplest method is to include a Maven dependency called Spring Boot Starter Data JPA in the Spring Boot application's POM file. A Spring Boot starter is a Maven dependency to conveniently bundle all the related subdependencies into one package. There are several Spring Boot starters. The Spring Boot Starter Web that we included during the previous two tutorials is also such a starter. Within this video, I'm going to demonstrate the microservice data persistent layer using Spring Boot JPA starter, which is essentially the Spring Data JPA based on Hibernate. Since I'm going to use a JPA for the demo Spring Boot application, this approach provides a couple of methods for me to create a database. The first method is to create the ORM classes within the demo application and then launch the application to let JPA to create the database tables automatically. The second method is to create a database and the tables first, and then use a reverse engineering tool to create the ORM classes within the app. Within this video, I'm going to show you the first method, which is my favorite way to create a brand new database. But I'm also posting the link for the reverse engineering tools below this video for your reference. Let's go to the Eclipse to show you how the first method is done. The first thing we need to do is to include the Spring Boot JPA starter in the app's POM file as a new dependency, like so. Since this is a starter under Spring Boot, we do not need to specify the version of this new dependency because it's controlled by the Spring Boot parent. We also have to include a database-specific library into the POM file. In this video, I'm going to use Mysql. So let's add the Mysql connector library into the POM file, like so. This dependency is also controlled by the Spring Boot parent, and no version information is needed. Now we are ready to create the entity classes. For this video, I already created two Podio classes. One is called checking account for a table called checking_account that stores data for a checking account. Another one is called transaction for another table with the same name that stores the transactions for any record inside the checking account table. I also converted the transaction class into an entity class using JPA's standard annotations. Now let's convert this first class checking account into an entity class. To convert this Podio class into an entity class, the first thing to do is to add two annotations above the class declaration. The first one is entity annotation to indicate this is the entity class. The second annotation is table to specify the actual table name, like so. Next, let's add three annotations to the class property for the primary key of the underlying table. The property is checking account ID. We can add either the annotation above the property or above the property's getter method. Let's add them above the property. The first annotation is ID. Indicate this is the primary key for the entity. The next one is generated value with strategy as identity. Such setting indicates that the persistent provider must assign primary keys for the entity using a database entity column. Such setting indicates that the persistence provider must assign primary key for the entity using a database identity column, usually an auto increment column in the table. The third annotation is a column to indicate the exact column name. We also make this column as not nullable because this is a primary key to the table. Next, let's add two annotations for the account number property. The first one is natural ID. This annotation indicates this property is an alternative ID column for the table and usually will be defined as a unique constraint on the table. The second one is the column annotation to indicate the column name. Since this property is a string and will be defined as a varchar column in the table, we also have to define the length of the column. We will also make this column as not nullable because it's a key to the table. For account name property, we will add the column annotation to only specify the column name. We will also make this column not nullable. The next property, transactions, is a hash set. Basically a collection of the transactions occurred to this checking account. However, JPA will not add any column in the table for this property. The existence of this property is purely for ORM. We just add the one-to-many annotation for this property to indicate that this is a bidirectional relationship to the transaction entity class object. We also have to specify mapped by as a checking account, which is one property in the transaction class. Now let's take a look at the transaction class. As you can see that the similar annotations has been added to this class. Notice the checking account property. There are two annotations for this property. One is many to one, which is a corresponding annotation to the one-to-many annotation that I added to the other class. This is how we establish bidirectional mapping. The second annotation is join column, which indicates the following key column referencing the checking underscore account table. Notice that bidirectional mapping is only for ORM. Underlying tables still be linked via the following key in the transaction table. Now we have the two entity class created. Notice that all I did was adding JPA annotations to the POJO class. In fact, that's all we need to do to define most of the entity classes. Just as simple as that. Before we launch the application to generate the database tables automatically, the last thing we need to do is to add the database connection related settings into an application configuration file called application.properties. This file must appear inside of the main resources source folder and is the default configuration file for Spring Boot. Here is the minimum list of the configuration properties that we need to specify in this file. Data source URL. This is basically the JDBC URL for MySQL. Since the database is on my local machine and it is running on its default port number 3306, the URL should start as Also, we have to specify the database name here. A database in MySQL is called schema. We have to create our schema ahead of time, as JPA won't create it automatically. I already created this schema called account, and we have to specify it at the end of the data source URL, like so. The driver class name must be com MySQL JDBC driver. Next, we specify the data source username. The best practice is to use a designated database user that can only access the microservices own database. In this case, I already created this user inside of MySQL called account restful user. For demonstration purpose, the password of this user is password. Next, we will also set the show SQL property to true so that the JPA will display the native SQL statements into Eclipse execution console. The next two properties are more specifically for Hibernate. The first one is Hibernate dialect. There are mainly three MySQL database engine types, and the most commonly used one is called InnoDB, which is meant to be used for any MySQL schema that needs to support a transaction. We will use this engine, and the value of this property will be the last property, Hibernate DDL, is the key for JPA to automatically generate the database tables for us. Its value has to be update. In this case, we do not use create, as JPA will update the table structure during the table auto generation process. Once the new table have been generated, we can change its value to validate, which will ask Spring Data JPA to validate entity classes with the underlying tables to see if they match. If mismatch does occur, the application will fail to start. So this is a good feature that you might want to use during the development and the production. As a good practice, you should only use validate in production environment. Now we will save this application configuration file. Let's start the application to see how the new tables will be automatically generated. To do this, all we need to do is to run this file to run as or debug as Java application. As you can see here, two tables has been created. Then JPA asked MySQL to drop the index of the primary key column of the checking underscore account table. Then JPA instructed MySQL to add a new unique constraint on the account underscore number column due to the natural ID annotation that I put on this property inside of the checking account entity class. At last, JPA added the foreign key inside of the transaction table to point to the checking underscore account table. Now let's go to MySQL to verify whether these two tables have been created automatically based on the entity classes. Now I'm inside of the MySQL workbench. First, let's refresh this schema to see these two tables. Let's take a look at each table. The first one is checking underscore account. As you can see that the JPA already asked the MySQL to create this primary key as auto increment, and also it also created the account name and account number, and then both are not nullable. The also has a unique key for the account number. The second table is a transaction table. Let's take a look. First, its primary key is also auto increment. It has a foreign key that is pointing to checking account table. Now it looks like these two tables has been generated automatically. That's it. This concludes this video. In next video, I'm going to show you how to use Spring Data JPA to perform database operations with these two tables within a new Spring component called Service, and how the service will work with the RESTful controller. If you would like to provide feedback, please leave comments below. If you like this channel, please subscribe. Until next time, happy coding!